Right, so like 2 minutes ago, you asked me to read this comic to you, and so I read it to you. And it's Calvin and Hobbes, and this is how it went. It says, I don't think math is a science.
Okay, how about you be Calvin, I'll be Hobbes.
Okay, that sounds good. Okay, I'm Calvin. You're Hobbes?
Yep.
Okay. I don't think math is a science. I think it's a religion.
A religion?
Yeah. All these equations are like miracles. You take two numbers, and when you add them up, they magically become a new number. No one can say how it happens. You either believe it or you don't. This whole book is full of things that have to be accepted on faith. It's a religion.
And in public schools, no less. Call a lawyer.
As a math atheist, I should be excused from this assignment. We're going to keep going here. We started having a conversation, and the conversation went like this. Why is 1 + 1 2?
Oh, I guess if you take a dot and a dot, and you put them together, that's 2.
Okay. Like, I can tell you that you take one dot, put them together, you get 2 dots. I get that. I totally get that. But I have no idea why 1 + 1 is 2. Just like I don't know, why 1 × 1 is 2. I just memorized that 1 + 1 is 2. 1 × 1 is 1. Right?
Mm-hmm.
So, I learned a bunch of stuff. And right now I don't know anything besides the magic behind the number.
Visualizing? I don't know. Like, well then wouldn't everything be religion?
Well, that's a good question, right? How do we, quote unquote, know rather than it being like it just is?
Mm-hmm.
How do we know that the number pi is 3.1415?
Maybe you guys are stuck because it's an English problem, not a math problem.
What do you mean by that?
Well, if you have 2 pens, if you have 1 + 1, maybe it's an English question. It's 2 because we've chosen the word 2 to represent this amount of things. It's an English problem.
Well said.
Maybe you need better English teachers.
Maybe we should bring English teachers in on this, but how does the concept of, let's go to, what we were talking about a minute ago, 3.14159, blah, 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 blah. I know that number because somebody told me to memorize that number. I don't know, I can't argue why that actually is a number. Now, you've learned about pies recently.
Well, it's what you get when you divide a circle by its diameter, the circumference, or by its radius times 2, or radius times itself.
So what does that mean, though? No matter what, whenever you do what by what, you get what?
Whenever you divide the circle's area by radius to the 2nd power, then you get pi. Whenever you divide circumference by diameter, you get pi.
So but why is that important?
Because it's a constantly used number.
For what?
For circles, for engineering.
Okay. So it's not a made-up number?
No.
It's something that every single time you do this specific thing, you get the same answer?
Yes.
Why do you get that answer?
Because we chose, Ed said, we chose that to represent that. We chose pi to represent the diameter or area/circumference of the circle. because it comes up, we chose a name for that object.
Okay, all right.
I think you're going to use that high when you're working with circles, no matter what they are. So I think if you're, I don't know, somebody that's in a factory trying to figure out how much soda to put in a bottle, you're using it for volume.
Yeah.
If you're a scientist, how much stuff goes in your beaker? I mean, I think it's for circles and for cylinders, and I think it has to do with circles.
Columns, circles, spheres.
Columns, architects.
Well, columns are cylinders. Or, I don't know, maybe. Not so.
So, how would you argue, is Calvin right or is Calvin wrong?
Depending on how you look at it, both.
Okay, so what would your argument be that Calvin is wrong?
The fact that we know that we don't have to put faith into the fact that 1 and 1, we decided to call this pair 2.
Okay, so we have a word to represent a concept.
Yes.
Okay. You can physically see that.
Yes.
Okay. And why do you think that Calvin is right?
Because depending on the way you look at it, believing that this is, you have to put faith into the fact that this is 2.
Okay. Thinking about being in your classroom, right?
Yeah.
Do you just sometimes go, this is how they're telling me to do it, and I got the right answer, therefore I can move on to the next thing? Or,
I like to understand it. That's just me.
okay, but sometimes, like Khorbin, I went years and years and years with not at all understanding why I did stoichiometry the way I did stoichiometry. I didn't know why I did it. I know, you don't know what stoichiometry is yet. But I didn't even know why. Like, I had no idea. I knew that grams to moles, moles to moles, moles to grams. I knew a plug and chug formula. I never knew why I did that. Does that ever happen to you in class?
Not yet.
Okay. All right. It's a beautiful thing. Thank you for your help. Khorbin Kern, Jason Kern, and this is Kitchen Talk. Peace out.